Welcome. Thank you for joining CNC 101, an introduction to E1 Technical. My name is Christopher Hariff. I'm the Director of Technology for Terillium. I have 23 years of JDE experience. That goes back to basically the first release of JD Edwards at the client live on B714, which was what you would call a very rough software system. But since then, I've moved on to Terillium, and for the last 10 years, I've managed their CNC team. You've got shots of myself there, along with my beautiful wife, Trish, who is the Senior Director for Office Depot at their Print Services Division, and our fur basie there. She does not always agree with how I prioritize my time while working from home. This is a series of technical webinars we're putting on. If this is your first one, you've missed the initial, which was on July 16th. David Toll, our Director of Managed Services, did a presentation on 9.2 to 9.2 upgrades. This is basically Oracle's approach of no longer moving by major releases, your 9.0s, your 9.1s, your 9.2s, but instead kind of doing a continuous delivery model through ESUs and tools releases. This kind of puts the onus on the customer to make sure that they're keeping their systems up to date, and he's giving you strategies and tools to continue to do so. Again, today we're going to be doing CNC 101, which is basically for the non-technical people who have to deal with JD Edwards, and just kind of give the standard terminology and systems that make up the day-to-day tasks of CNC. And in a couple of days, on Thursday, we'll be doing a presentation on 64-bit. Oracle released 64-bit a couple of years ago, but so far it's kind of been slow to be taken by most customers. But in the near future, it's going to become more of a requirement, because things like your enterprise server and fat clients currently run in 32-bit architecture, and it's getting more and more difficult to get supporting JDKs, ODBCs, and other tools to work with the JDE system. So we'll explain, the benefits you'll get from moving to 64-bit, and what it'll take for you to make that jump. And then next week we'll be doing a safeguarding E1 from external threats. This will basically be looking at different strategies you can apply at the network, database, and E1 level to make sure you're protected from malware and internal and external threats. If you miss any of these, they will be available by recording. You can get these at the link below, and you should also be able to find the links through our Terillium website. Tell you a little bit about Terillium here before we get going. Our bread and butter is doing net new implementations and upgrades. We also do software licensing, and we currently have about 100 customers under our managed services support. On the JDE side, we've got 10 CNC consultants. They're kind of loosely divided between project work and our managed services work. And beyond just the implementations and upgrades, lately what we've been doing a lot of is just pushing up to the latest tools releases to get people access to that orchestrator tool. We won't be diving too much deeply into the orchestrator tool, but it is a great new product that's really opening up all kinds of new functionality for the JDE user base. We also do a great deal of moving people to hosting sites. There's been kind of the rush to the cloud, and we've been doing a great deal of that either on its own or as part of an upgrade or a tools release upgrade. And then there's also been an uptick in performance engagements. The longer people have their systems, their performance tends to degrade over time, either because of larger table sets or for new functionality. And so it's important to keep an eye on making sure you're sized properly, your architecture and scaling, but but also that you have the proper indexes and settings set within your system. As JD Edwards, we do have over 170 full-time consultants. You can see that there's an average of 16 years, so the majority of us are what you'd call lifers. We've been in this game for a long time. I think close to 50% of our people are ex-JDE Oracle people. And then another great sign we like to look at is that 100% managed services customer retention in 2019. We're very proud of that, and it shows how hard our consultants work to keep our customers happy. Trillium does supply a monthly newsletter, which will give you new information either about our offerings or information coming out of Oracle. I do highly recommend that you sign up for this. Oracle does have a great deal of information out there across its various websites, but it's easy to get lost in that. We do try to push out the important things to you. So instead of you being the one who has to go out there and find each of this new bits of information, or when a new tool is released, we can push that out to you. I do have David Toll on as a moderator here today, so he'll be reviewing your questions as they come in. You should have a little question bar on the right of your screen. If you go ahead and fill out the question at any time, he'll either respond back to you when able, or I've got several points within the presentation that will stop and we'll handle the questions that are out there and available. So again, today our focus will be on CNC 101, configurable network computing. Configurable network computing basically comes from the flexibility that the JD Edwards software provides. You should know that it has multiple choices of platforms, either at the OS level and the database level. And it also allows you great flexibility on how large you need your environment to be. If you can go with the standard environment and path codes of dev, PY, production, and pristine, or if you have additional needs and want things like QA environments or conversion environments, training environments. So we're kind of going to go over the medium details of the path code environment structure, and then we'll jump into servers in this first section. And hopefully, as you can see, I won't stick to the acronyms too much. CNC is more than a bunch of acronyms, and here's your list. Of course, I'm just putting these here not to go over them with you, but just to make sure of two things. One, if you decide to download the presentation, that you can use that as a reference set. And two, it helps to remind me to stay away from using any of the acronyms if I haven't explained them during this presentation earlier. Okay, again, so it'll be path codes and servers, then the server management manager tool, which helps us manage the server architecture out there. And then once we have kind of what it takes to install the system between path codes and environments and servers, then we'll talk about managing change through the system. That would be applying updates from Oracle and creating them ourselves, and the tools we use to manage those changes and deploy them out to the system. So everything basically starts at the path code and object level. An object within JD Edwards, we have several different types listed below. We basically have our applications. These are the interactive systems that people sign into and make changes, your address books, your sales order entry, your inventory management. We have our reports and our versions, which kind of modify the applications and reports to make them work differently for you without having to rewrite all of that code. The tables, which contain not only your data set, but also the programs. So the actual applications, reports, and versions sit within the tables, just like your user data does. And then we have business functions. Business functions are the actual business logic behind your applications. So when you say add or delete within a given application, the business functions are what's really doing the work in the back end and adjusting the database. And your business views are basically ways to look at the data in the tables. And the data structure is a way to access that data from the applications. And named event rules are basically very close to business function. They provide a lot of that back-end processing for our applications. So altogether, between these objects, we've got thousands and thousands of objects. When you put them all together, what you have is a path code. When we install JD Edwards out of the box, you end up with sorry, little delay there. We end up with 4 path codes. The development path code, prototype, production, pristine. So you're essentially getting 4 full copies of every object in the system laid in. The development object set is basically meant for your development people. So when you go ahead and apply new code, either from your developers or even through Oracle, it's applied there first, and we end up doing application testing there to make sure that the code is doing what's expected. We then can also apply that to the prototype environment. This is usually beyond where unit testing occurs on the development side. This is where more integrated testing happens, where you don't want to just see if this object works, but how does it affect other objects in your business processes or in your interfaces, and making sure that that is successful. And then finally, your production object set is the set that your actual end users are using to run your business. The fourth one is pristine. This is typically kind of an administrator-only path code. Basically, none of your custom modifications ever are applied to pristine. We want to keep this as clean as possible for 2 main reasons. If we run into a problem in one of the other environments, and for some reason one of your business processes isn't working, we can go ahead and test in the pristine, which runs across a smaller data set delivered by Oracle. And if we can go ahead and repeat the errors that we're seeing in the other environments in pristine, we know it's not some problem with your custom modifications or your data, but instead it's related to the actual code being sent from Oracle. And the other option is if you have gone ahead and modified, say, your objects in development, prototype, and production, and want to get rid of that change because it's either not doing what you expected or it's causing other issues, you can go ahead and pull those objects out of pristine and get your development, prototype, and production path codes back in order. The fifth and final path code is a planner path code. This is kind of a special path code. It is only available to the administrators and only available from the deployment machine. So it's not part of your lifecycle management and never really gets updated with the products from your development, prototype, or production environment. So we're going to talk about that a little bit more later. But for now, let's focus on the first 4, and primarily the development, prototype, and production, because that's the ones that your users will actually be spending their time in. Along with the path codes, we match those up with environments. You can see here on the left our different environment names and how they kind of line up to our path codes. So even the development and path code and environment have the same name. This can make things easier and a bit more confusing within the JDE system. But basically, when you think of an environment, you have to realize you have your object set, which is that path code, and you're matching that with your actual business data. So having a bunch of programs with no data doesn't do you any good, and having a bunch of data doesn't do you any good without anything to manipulate them with. So by signing into an environment, you're deciding which object set you're looking at and which data you can start to affect. Again, so we have the standard development, prototype, production, and pristine. There is also a deployment environment listed here. And again, that's accessed only with that planner path code on your deployment server, which we'll be talking about again in the future. And then also you should realize that, again, just because we put in the standard path codes, the CNC aspects of JDE allow you to modify how the system's created. So I've listed 2 additional environments that we'll often see at the customer sites: a conversion environment and a training environment. So just because you have a development environment that's matched up with the development path code does not mean that this has to be a one-to-one relationship. What we find is path codes are actually much more difficult to manage than an environment, because with a path code, you're dealing with object updates from Oracle, electronic software updates or tools releases can affect those. And you have to push out packages and make sure that that code is available to your users in a bunch of different areas that we'll be reviewing. A data set, however, is much easier. Typically, you're really only managing, once you go live, your production data set. And what you'll end up doing is doing refreshes back from that production data set, say your test environments, to make sure that when your testing occurs, it's in a timely data set method, meaning people have reasonable dates, but they have customers that they're frequently dealing with, which just helps keep their testing more accurate. But you can also say, we also often will create a conversion environment, say, based off the development environment during your implementation period. And we'll use that to bring legacy data in. So while you might be setting up your chart of accounts or your business units in DV or PY, you're going to be constantly reloading and loading from your conversion environment, bringing in legacy data. Another very frequent used environment is your training. So you might want to set up different scenarios of training that you can go ahead and refresh over and over to train different sets of users. You can go ahead and create that as a side environment that people would have access to. That, again, won't affect you putting together your implementation work, but will allow users to train on the system and become more used to the interface and business processes. You will notice that there's this additional J environments in your environment master tables. The J environments use the exact same object set and the exact same data set as the non-J environments. The only difference is where they process their business logic. These are meant for your web users. Basically, web users are sitting on a browser type platform, and they don't have those business functions in the background to go ahead and process that on the web servers. So instead, what the J environments do is say, hey, please take all of this business processing and push it to your enterprise servers, which, again, we'll be dealing with in a little more detail. Now, your environments basically are made up of data sources. There are 8 main types of data sources in the system. The first one is the system. In the most recent, it's called system-920. This holds all of the information for your configuration. So that path code master and environment master tables we looked at are stored in your system, as well as all of your users and your security system. All of that is contained in what we call your system data source. And a data source basically is a collection of tables. And that data source is how we can go ahead and find and locate those tables. When we talk about path codes, we really want to focus on Object Librarian. Object Librarian basically has a record for every object that's in the system. And it also has one for every object for every path code in the system. What it does is it tracks what last changed that object, who has modified it, and at what time. And then when you do promotions, which basically means moving objects from one path code to another, it tracks that work and makes sure that you're not overriding, let's say, your newer specs with older specs. It provides those details. Data dictionary defines objects within your system. So when we look at a table, it might have multiple columns. One might be an address book number. So a data dictionary would say, okay, this is a numeric value up to 20 characters. Or there might be a description level that says, hey, this can be alpha or numeric up to 600 characters. All of those items are defined within the data dictionary, and it tells the system basically how to read that data and what data is acceptable in a given area. Server maps, they kind of are how the system looks from the server from its perspective. The main thing it does is it contains the job table. So anytime you go ahead and process a job or submit a report, it's the one that contains it, reads that table to make sure it knows how to process it, and then brings back the results. Central objects and versions. These are both basically data sources that point towards where your path codes are stored in your database. And then we know about business data. This is both your transactional data, so a sales order or inventory item, but it's also the setup. How many business units, how many companies you have, what are your chart of accounts. And then control tables are the next numbers for your business data, UDCs or user-defined codes, and the menus within are stored within there. And that's so that the business data and control tables are kind of closely related, just like your central objects and versions are very closely related. Okay. So again, a better look at the data sources. Here we're looking at a control table data source. This one's for control tables production. And what it is, again, is a pointer to a set of tables. So here we know that it's sitting on a platform of NT. It's in a database called JDE SQL DB01. It has an object owner, a prod.ctl, a database name of JDE production. And if we're accessing it by ODBC, we know what the ODBC name would be on a given client. And you can very easily match that up to the actual database. So here we have a Microsoft SQL database. You can see that the database server name, JDE SQL DB01, matches here. We have a JDE production database matching to the database name. And then here we have our control tables. So this first one is a next number table. Here we have a UDC table. And you can see that the object owner is prod control. So that's for control tables prod data source name. So just by looking at a data source, the system knows how to make a connection to your actual SQL database. So again, it's a pointer to a listing of tables in your system. OCM, or Object Configuration Manager, is what ties together an environment with a data source. So I hope you can see these tables on the right, but I've basically set up 3 different QBEs, query by examples, to bring forth the data for how the OCM finds data within the system. So the first one we're looking at here is if I'm a JPD 920 user, so that's your standard web production user, where do I find certain big items? So the first one is, where do I look for by default for my tables? And here we can see that the production environment looks at business data prod for all of its standard tables. It's going to show you when it does a UBE. A UBE is a universal batch engine or a report that it's going to point to the JDE and ENT01 enterprise server for it to process that report there. And then the business function, again, going to that same server for logic processing. So again, we said all of the web servers, they can't process their own logic. They have to send those business functions elsewhere. Here it's showing you sending that information to the enterprise server. And then we have some kind of advanced default objects here. These are for real-time events. That's if you want to trigger an event from one of your tables to an outside resource. And Zappy is a different communication style. But I think we should really want to focus on the top three here. Where are we finding our default tables? Where are we running our UBEs? And where are we running our business functions? If we look at same thing for production, but just for the tables, you can see that, again, for the default, it's the business data prod, but for these different tables, it's showing you different data sources to go to. And so we were just reviewing the control tables prod data source, and we saw that next number table and the UDC table. So here, you know, when you're signing into JDE, PD 920, if a table isn't inherently listed, it's going to go to this default business data prod data source. And mostly they do that because there's like 4,000 to 5,000 tables in business data prod, while there might be only 100 in control tables or 100 in system. So it's just a way to keep the records down. Okay. And then if you look down at this last table, again, we'll see our full list of environments here, and we're looking for the default for all of them. So here you see we've got DV920 and JDV920. They're going to go to business data test. That's going to be that new data set that the development environments are going to look at, as opposed to the production one. Again, for PY, we have business data CRP, and then for production, we have business data prod. And we also have our pristine here. So the idea then is by signing into an environment, you know by looking back at that environment master which object set you're going to use, because it's got an attached path code master. And then it'll go here to find out where it should go for every other table in the system, starting with its business data. And these all will tie back to the data sources so that the system can actually go out there and access that physical data. So this is a very old diagram. I've been putting the 9.2 numbers at. I think I started with 7.33 on these a long time ago, but I just think it's a great example for you to understand the relationship between the path codes and the environments. So again, we laid down 4 standard path codes right at the beginning. Again, that's a copy of every program in the system delivered 4 times. And then there are versions that, again, we can adjust slightly to change how those programs work. And then we tie that together with the environment. So the environment is not, one of these boxes. Each box is actually, a database within the system. The environment is the relationship between them. So when we create that dotted line between the object set of the DV path code and the business data test data sets, that combination provides us with that DV920 environment. Same thing here with the production. So we've got the production path code, a business data prod, and control tables prod, and that relationship creates the production environment. And again, here in the red, I've shown you how we don't have to have a one-to-one relationship between path codes and environments. So here we're using the same DV path code as development, but we've got a whole nother data set that we can go ahead and manipulate. Here again, we kind of said for conversion, this is we could continue to run legacy conversions into until we've gotten that conversion right and we're happy with how the data is in our environment. And then perhaps we can run it within DV or CRP or prod and kind of get rid of that environment, but it becomes very handy in the beginning. Just like in train, during that initial implementation phases, you may need an extra environment so that you can constantly be refreshing data without affecting the work you're doing in your other standard environments. I've also highlighted it in green here, the different data sources that we went through that we consider the production data sources. So within production, we have your central objects and versions, which compose your path code, and we have your business data prod and control tables prod, which kind of provide your transactional data and your setup data. In addition, we listed those other data sources in the beginning, which was your system, data dictionary, object librarian, and server map. So these data sources are shared by every environment. Again, as we said, system has like your user profiles. It has the environment config. So these, in a sense, become production because the production environment cannot operate without them. So when we start talking about production versus non-production servers, you need to realize that these shared ones we are always going to consider as part of production. There's another shot of Maisie. Anybody have any questions at this time? David, are you out there?
Yes, this is David. Chris, at this time, there's no questions out there, but just to remind everybody, if you do have a question, feel free to enter it into the questions box and we will answer it during the next opportunity.
Okay, thank you very much. We'll press on. JDE architecture. Again, the key thing here is we have a bunch of different selections on platforms and databases we can run on, but the end user should never really care. You know, those applications run the same if they're on an iSeries or if they're on Oracle Linux or if they're on Windows SQL. And this is all based off of a three-tier application system that JDE Edwards is based on. Basically, we have a presentation tier, which is how we present the system to users through a web interface or even through integrations through different web interfaces like AIS or business services. So basically, everything comes in through that presentation layer. The logic tier is what our enterprise servers, and this is the thing that actually provides the logic of the system. It manipulates the data either through those business functions or through reports. And then the data tier is your actual database layer. So the database is what stores that data set that you're manipulating and also all of the programs within the system. So some of the first things that we do when we're designing a system for JDE is make some choices. You know, do we want to be hosted or do we want to be on premise? Obviously, things have been moving pretty significantly to a hosted level. But you know, that kind of comes company by company has to make their own decision. You know, typically this is not based solely on cost. In fact, hosted can often be a little bit more expensive than on-premise, but it does offer you a bunch of different options on, you know, HRA and DR. It's a lot easier to have a disaster recovery system that from a large hosted provider than trying to come up with your own and test it and have multiple sites. It also is a little faster. You know, with these hosted providers like Amazon or Azure, you can kind of pretty much spin up servers in just minutes through their interfaces, as opposed to what it would take your people to end up either purchasing new servers and you know, loading OSs and getting those online and on your network. We'd also want to do a choosing of our platform, which we'll get into more detail. And your scaling model, you know, how many users do you have to support and how many business processes? Does that mean you need one really big server, or do we need multiple smaller servers that we can load balance? And then, you know, do we need to split up our systems? Do we want servers that are only for production and others that are for development, or are we going to run those on the same system? You know, by creating a split there, we're able to provide patching at the OS or database layer to the development area before we go ahead and affect production. And also, if somebody does something a little crazy on the development side, it runs open queries, makes a program that, you know, isn't using indexes properly, you know, if it's all on one system, we can often see degradation of performance that you don't want to have affect your production side. And then other options are, you know, will this be only accessible from within my network, or do I want to provide this out to the external environment, to the internet, where nobody has to, you know, like sign into a VPN first, but can access it directly from a browser? So first we'll jump into choosing a platform. Again, I've put these in roughly the order that we see them out in the public and with clients. The first most popular is a Windows SQL. Next will probably be Linux Oracle, Windows Oracle, and iSeries. There are some additional options that we see very infrequently, Sun Solaris and UDB, but it seems like Oracle is kind of moving away from those. So I would not recommend going to one of those approaches. We should probably stick to the ones that we see the most of and most testing occurs on. And some of these are slightly different based on regional area. You see a lot more of the iSeries in the Midwest manufacturing area. You see a lot more Linux Oracle on the West Coast. But in general, any of these platforms are available. And the question I get most of all, well, which is the best platform? Typically, that there's no real good right answer for that. Mine is the one that you can best support. Windows SQL, is the easiest to manage. Everybody has Windows experience. SQL database really almost manages itself. While Linux and Oracle, you need a more specialized skill set to manage Linux and certainly the Oracle database, especially when you get to more advanced rack or data guard solutions. And then the iSeries, is a very strong system. There's not much of malware or viruses that are ever going to affect it. But again, it's very difficult to integrate with from other outside systems. And it's getting harder and harder to find iSeries admins as that platform gets older and older. So again, what I would focus on is what do your people know and how easy, will you have a chance to support it? Okay. So the first thing we'll discuss at the architectural level then is our web servers that, again, provide that primary presentation layer. Again, it can be on Windows, Linux, or an iSeries. It's basically, Java programs running on any of those platforms. And we create containers within these web servers that host different pieces of the JDE system. The HTML system, application interface servers, and business services are all kind of outward-facing web servers that take information either from direct end users or from third-party applications. They create these processes to process all of the requests from those, and then we kind of size that up with vertically by adding additional memory to that JVM process. Or we can go ahead and split it out, first by production and development. This is the first method we would typically go, and then we can go ahead and add load balancing techniques to increase the size of the information that they can handle. And again, if you're going with an external access, we would highly recommend you putting SSL on these to protect your information from being open on the networks, and to use a DMZ to make sure to protect yourselves from any viruses coming through open ports. So again, the web server HTML, everybody should be kind of familiar with. This is a standard opening page with a great deal of E1 pages being added. It's kind of the new method to present our system as opposed to the old menu structure. Typically, we need one of those JVM processes built for every single path code. And again, if you have, say, over 70 to 80 users, we start thinking about load balancing and providing more of these servers either on the same web server, or we would provide multiple web servers with HTML that we could load balance either with smart switches like an F5. We can use a network alias, which just kind of round robins people as they come in. Or both of those web servers, WebSphere and WebLogic, have clustering, which we can use as well to load balance these systems. The AIS is kind of a relative newcomer to the systems. It'll become a major part of the UX1 functionality that's kind of come out lately with the 9.2 tools releases. AIS has always handled mobile devices, so phones and iPads, things like that can go through the AIS, as well as Internet of Things and UX1. So any work for your orchestrators, watch lists, your UX1 schedule, all of these items communicate first through the AIS server, which then translates it into information to process through the Enterprise One HTML server. Next part is the business services servers. These basically handle third-party integrations in real time. So an example of this is when, say, you're writing up a sales order and you're using a third-party shipping firm. You may send a request out with your shipping information, number of pieces, and weight. It'll go ahead and process that information and come back to the E1 system with a price for what it would cost to ship. So all of that real-time integration, immediately being able to update that pricing, would be done with the business services servers. Okay, so that's kind of the presentation layers, 3 ways to get information into the system. And that next tier is that logic tier. And that mainly is what we call the enterprise server. Again, Linux, Windows, Linux, iSeries, any of these can do it. Basically, when you start up services on one of these servers, it starts up a list of different kernels. There's logic processing kernels, also known as call object kernels, that go ahead and process that interactive user information. So again, hitting add on a sales order sends that information to the enterprise server that then communicates back to the database and updates your tables with the business data changes. It also does your reports. So any report sent through the system, when people log in, it validates that they have a proper password, and it also validates which applications they have access to run. It can do scheduler activities, so setting up reports to run automatically, and workflow messaging. If you had said you wanted to raise somebody's credit limit, per se, it could automatically send messages through the system to people who have the right to approve those type of requests. And again, we've got several scaling opportunities here. Typically, we do a production or non-production split. That would be the first way we'd scale. And the second one we like to do is separate the logic and report functions. That's to make sure to say, if you have a bunch of reports processing at any given time, you don't want to slow down your the users using their your sales order or address book records. Any type of interactive processing, needs to be as quick as possible because you have a person waiting for that. So by separating the logic and the report, you guarantee that performance for the end user. And then we've got the database server, which is that third tier. Again, we're looking at IBM, Oracle, SQL. There's no actual JDE components installed on these machines, unlike the others. This is basically using standard database information. The only thing we do is use database scripts to create the databases and the users and the tables that JD Edwards needs. But after that, it's all basic database functionality, and we're just kind of accessing it through standard database clients like ODBC and JDBC connections. Going back to that picture where I showed you all the boxes in that environment config, all of those boxes still kind of have a similar architecture no matter which of these database platforms you're on. So I showed you that control tables prod, which was a database within the SQL database. That same box is basically just known as an Oracle schema in the Oracle database or a library in the IBM. So even though we're looking at vastly different databases, the way JD Edwards deals with them is all remarkably the same. Again, for HI and DR, since we have no real JD Edwards software on here, what we're really doing is relying on the inherent native database tools to go ahead and provide those type of solutions. So again, clustering, rack, or the Mimics AS400 solution. Okay. All right. The next machine is the deployment server. This is not actually part of that 3 tiers. This is only meant for administration. You could actually turn this server off and your end users would not have any effect. It is really only based for setting up the initial system. We use that planner environment to plan which path codes and environments you want installed on the system. And using that, we kick off processes that create those and load the system tables with that information. It has to be a Windows-based machine. It has a little local Oracle database on it. That's actually what stores that planner path code we were talking about earlier. And there's some additional tools we use that are normally placed on the deployment server, a change assistant, which we'll get into, and server manager. Okay. So the main thing is that initial install, and then it's also how we go ahead and apply updates to the system from Oracle with electronic software updates. And then it plays a large role in how we send out those updates through package builds and deploys. Development clients are, again, Windows-based machines. They have additional tools that we load onto them for development. So basically, there's design tools that allow you to create new objects like applications or reports, or to modify existing ones. All of that has to be done through the development client. And again, we can only do certain administrator functions on the DeFat clients or the deployment servers that aren't available on your deployment server, mostly surrounding around package builds, development, and your scheduler. Typically, we would say that we want these to be a dedicated machine. Some people put these on their laptop or something like that, but because these are meant to also not just do development, but provide their own testing, they have a local Oracle database so that they actually have their own copy of a path code locally, and they have a local web server so that they can go ahead and test the things that they're developing right on their own machine without affecting anybody else until they feel that the testing has gone successfully and they want to push it to the other users. So these things are not small. They've got the JD Edwards tools, they've got a local database, they've got a web server, they typically have Visual Studio. All of these items make for a very big machine with a lot of complex parts. So typically we like to say, put this on a dedicated machine that people can RDP and share in instead of trying to give everyone their own copy. And then the web client, or really the end user machine, basically that's just a browser. We support several different browsers, i.e. Edge, Chrome, Firefox. What we'll normally recommend is a client go ahead and select one of those and try to keep to it. All of these browsers have different finicky parts and different security aspects. So sometimes it's easier to kind of find one of these, find out what the perfect settings are for your company and your business processes, and just kind of push that out to everybody, as opposed to trying to troubleshoot 5 different browsers and having to question each end user, well, which browser we're using at this point. So normally we would suggest choose one of those and stick with it. The only other pieces that you typically need on a thin client would be your Microsoft Office. This helps with Excel, so you can import and export data. And then all of the reports are typically delivered through PDF, so you would need an Acrobat viewer as well. With all those servers, thankfully Oracle was good enough to give us an administration tool, and that we use Server Manager. Again, this is typically installed on the deployment server, and it's a web-based application. Basically, all of the different servers that we talked about. Here we have an enterprise server, an application interface server, HTML server. All of these servers are placed on their VM, and we add an agent, which allows them to talk back and forth with the server manager. So here we can see all the different servers that have an agent on them and what's been installed on each one of those servers. And the little green arrows mean that it's successfully running. Through this, we can see user sessions. So here we have a list of users, which environment they're on, which browser, how long they've been idle, which is always somewhat valuable to see, and then which applications they're running. So this gives you a great view into what your community is doing, your user community is doing at any given time. We can access logs from Server Manager. So it'll give us information on any issues that people are experiencing. And if it gets bad, they'll kind of highlight in red. So it'll really kind of show you the different areas that you should be reviewing. Another special function of the Server Manager is removing cache. As you make different changes to E1, not all of it always appears automatically because the system caches information to provide it more quickly to the end user and increase performance. But that means when you've gone ahead and made a security change or a menu change, that you may need to go in here and remove the cache to allow it to be reloaded and users to have access to that new information immediately. Server Manager also allows you to add monitors to the system. So we can go ahead and say, hey, if one of my instances, like my enterprise server or the VM hosting my enterprise servers goes down, go ahead and not notify me. If I get more than 75 users on an HTML server, please notify me. So it's a highly configurable way to kind of set your data up and have it emailed out to an administrator, user, or group so that they're aware of the information and can react before the users start experiencing issues. It also helps us adjust the configuration within the system. So this is like an INI file on the batch server or enterprise server. We can go ahead and update that without going into a text editor. And it does a couple of things for us. One, it kind of provides us information on what each one of the settings does. And here, it's keeping track of changes, what was the previous values, and who made the change at what time. And then also, sometimes it becomes difficult when you're looking through a config file to see what is a valid value. Here we can do a drop down and say, what is a valid value? Sometimes it's true, false, sometimes it's yes, no. So this will go ahead and provide that information ahead of time so you're not making a bad input. Okay. David, any questions on the architecture or servers and server managers?
Yes, we do have a couple. The first one comes and says, do most of our customers have separate AIS and HTML servers or just separate instances of the HTML server and AIS server on the same physical server? I'm assuming there's no right answers, but just kind of know what it kind of depends on and how you decide.
Yeah, so typically I'm going to say that that's kind of a scaling question. Again, we only want to see somewhere around 75 people to an HTML server, and I don't want to see, say, more than 4 different instances of a JVM on a server most times either for your end users. So if you've got that many already, then I would say, hey, let's scale this vertically and move your AIS server to another dedicated machine. So what I've been doing frequently is putting like end user HTML sessions on one machine, and then I'll move your AIS and your ADF and your orchestrator type instances to a separate UX1 based server. But as David said, it is kind of based on your usage, and there are no real wrong answers there.
Related question is, do you recommend load balancing the AIS traffic?
It is rare for the AIS traffic to get that heavy. If you had, hundreds of mobile users out there, then you may need to do it. or if you were doing really high volume integrations. But typically, it is not doing a ton of work. It's more of a translator. So we haven't had to do that very often.
All right. The last question I got right now, so if you guys want to enter more, feel free to enter them into the question box. But the last one I have is, are you seeing people move from BSSV servers to Orchestrator? Is there still a need for BSSV now that Orchestrator is getting more and more functionality?
David, let me throw that one back at you.
Sure. Short answer is that we are seeing some movement towards Orchestrator, especially since they added the ability to call business functions directly. However, there are some cases where, while there's overlap, there are differences between the two products. And one does play better in certain times than the others, particularly a lot when it comes down to the protocols they use. One uses SOAP versus REST API using XML versus JSON. So it really kind of depends a little bit on what third-party product you're using and what type of integration you're doing. Hopefully that answers that question. That's all the questions we have at the moment, Chris.
Okay. Well, we are running out of time. I had hoped to get to our ESU application area, but I'm afraid I'm going to have to call it. We will be doing more of these technical BA and developer webinars. So please keep an eye on the system, and we will try to send out updates as well. Again, if you have any questions, please reach me at chariff@trillium.com. And I thank everybody for joining.
Thank you.